Using the LCD method, we first have to consider all the different denominators in the problem. My denominators are 2, x, and 1. In here, I have a 2, I have an x, I have a 1. This will go into anything whatsoever, so I don't really have to concern myself with that one. But if I were to get the entire denominator, where everything is accounted for, with the 2, it happens to be missing an x. With the x, it's missing a 2. With the 1, it's missing both the 2 and the x. So my common denominator, my least common denominator, would have to include all of the denominator pieces. So my LCD is 2x. So LCD equals 2x. Now what I need to do with this is multiply each term, each piece. There are 3 terms here. 1, 2, and 3. I need to multiply 2x by each term. And what will happen as a result, since I'm using the least common denominator, all of our denominators will be eliminated. And that's our goal. So if I take 2x and multiply that by 7 over 2, and then I take 2x and multiply that by 3 over x, and then take 2x and multiply that by 4, my result will be below. One at a time. So 2x times 7, my 2's will cross cancel. So that gives me 7x. For my second term, the x's will cancel, so I get 2 times 3, which is 6. And for my last term, nothing cancels away, so I have to do 2x times 4, which gives me 8x. Now I'm left with an equation where I need to solve for x. So I need to regroup. Since I have variables on both sides, I need to regroup. It's the easiest to bring the smaller one over to the larger one, always using opposite signs. So my 7x will cancel away. I've got 6 equaling 8x minus 7x equals 1x. And that is the solution right there. So x equals 6. The only thing left to do now is to check by plugging in the value, make sure it works. So when I plug in a 6 for x, I'll have 7 over 2 plus 3 over 6 equals 4. This is my check. 7 halves plus 3 sixths. 3 sixths is equal to 1 half. 7 halves plus 1 half is 8 halves. And 8 halves, we know, is equal to 4. So it works.